Hey Marie, I thought the easiest way to answer this question would be to make you a quick video. Um, all three of the problems here in this MyLabs Plus example are going to be very, very similar. They all deal with the same region. They just ask you to rotate it around a different line, but all the lines are horizontal, so the way that we're going to do them are all going to be very similar. So you can either you could graph these on your calculator to see what they look like. But these are the two functions that are going to enclose our region, and those are the only two functions that are enclosing our region. Let me make my pen a little bit darker here. Oh yeah, there we go. Okay, so we've got y equals negative x squared over 4. So that is an upside down parabola. And the divide by 4 makes it open really, really wide. It's got its vertex at the origin. So if you were to plug in 0, you get back 0. If you were to plug in 1, you'll get back a negative quarter. So you've got to go out to 2 and negative 2 in order to get 1. So it's pretty wide. So there's our parabola, roughly. Y equals negative 1 is the other boundary. So this is our region right here that we're dealing with. That's the region that gets enclosed. The first thing that we are asked to revolve it around is y equals negative 1, which we have just drawn. So anytime we want to revolve around a line that is parallel to the x-axis, what we actually have to do is we have to shift everything in this problem so that that axis of revolution lines up with the x-axis. So everything in this problem needs to be shifted up 1 unit. So our parabola, everything in the parabola needs to be shifted up 1 unit. And our line needs to be shifted up 1 unit. And that's so our axis of revolution will actually fall on top of the x-axis. So what I like to do first, before I set up my integral, is write out what those two functions would look like if they got shifted up 1 unit. So y equals negative x squared over 4. To shift that up 1 unit, you just add 1. And then y equals negative 1. To shift that up 1 unit, you just add 1. So our first one doesn't simplify at all, but our second one simplifies to 0. And then our disk method says volume is pi times the integral. Well, we said this thing goes from negative 2 to positive 2. Those are the intersection points of these two boundary functions. The parabola is farther away from our axis of revolution, so that one's going to be written first. So negative x squared over 4 plus 1 squared minus, and then the line is closer to the axis of revolution, and actually once we shifted it, it actually is the axis of revolution. It lines up right on top of the x-axis. It ends up just being 0 squared, and it goes away. So really all we end up doing here is negative x squared over 4 plus 1, that quantity squared. You could either type it in your calculator at this point, now that we have it set up. If you wanted to work this out by hand, you would have to FOIL this out because it's a binomial squared if you wanted to integrate it by hand. So all three of these, A, B, and C, are all going to use this same region. They just ask you to do different axes of revolution. So the first one is y equals -1. So everything has to be shifted up 1. So for the second one, it says use y equals -2, which is right here. So everything's going to be done the same, except instead of adding 1 to our functions, we're going to add 2 to our functions. Because in order to get our axis of revolution up to the x-axis, we've got to add 2 to everything, because this is y equals -2. Now, the y equals 1 problem ends up very different. With y equals 1, the reason that one is very different is because y equals 1 is above this region. Let me change colors. Y equals 1 is up here. So, in order to work this problem, we would have to shift everything down 1 unit. So we would subtract 1 from both of our boundaries. It's also going to change what the outer radius and the inner radius are, because you're always moving towards your axis of revolution to decide what is the outer boundary and what is the inner boundary. So now, so those A and B, you were using axes of revolution that were below your region. So the parabola was on top and y equals -1 was on bottom. So the parabola was the outer boundary and y equals -1 was the inner boundary. But on part C, y equals 1 is above the region. So you're moving towards that axis in a different direction. You still shift exactly the same way as before, but the order that you do that subtraction is different, because now that line is the outer radius and the parabola is the inner radius. So for that one, we would say for part C, volume is pi integral -2 to 2. Now the outer is y equals -1. But we have to shift everything down 1 so that y equals 1 lines up with the x-axis. So I would subtract 1 from it. And then the inner radius is the parabola, and we also have to shift that down 1. Everything has to be shifted down 1. And then we could probably simplify that a little bit. And then if you wanted to work it out by hand, you'd have to do some foiling, or you could type it in your calculator to finish it out. So part C ends up just a little bit different because the order of the subtraction changes once that axis of revolution jumps to the other side. But A and B are very, very similar because both of those lines are below your region. And the first thing you should do is you should shift both of your functions, and then you can plug them in and do your outer radius minus your inner radius in your disk method formula. So I hope that helped. If it didn't, I'm sorry. We could go over it in class on Tuesday, because this won't be due till Tuesday night. So if this didn't help, if it didn't clear it up, then we could do this one on the board on Tuesday, because there might also be some other people having some trouble with it.